already. You know that cosecant is the reciprocal of what? Sine. Cosecant is 1 over sine. Secant is 1 over cosine. You knew all this from before when we were solving equations. Cotangent is 1 over what? Tangent. Seriously, again? Should be. Cotangent was 1 over tangent. And now I want you, oh, first of all, are you guys mad at me if I don't put x's or thetas in there?
No, just a little bit, but it's okay.
All right, here's the deal. Every one of these things in order for all these identities and things like this to work, that theta value, that x value, whatever you want to look at, they always have to be the same value. It can't be cosecant of theta equals 1 over sine of x. Those values will always have to be the same. So it's cosecant of x, 1 over sine of x, or cosecant of theta is 1 over sine of theta. Those angles always work, okay? They're not going to mix and match. That's kind of why I don't put in those angles, plus I'm taking 25% of our workload away.
Yay.
1 letter out of 4 is 25%. Anyway, now, by rules of fractions and things, I think that's a thing. Sure, sine is also 1 over cosecant. Just remember the old-fashioned exchange-o change-o on the diagonal? What's that? Cosine would be 1 over secant. Oops. And tangent would be 1 over cotangent. Now, these are the 3 basic trig functions and the reciprocal properties. Sine, cosine, tangent, reciprocaled out at cosecant, secant, cotangent. Of those 6, basically, 2 of them are made up of something. Which 2 are made up of something? Make up what? Tangent. Which means that tangent is what over what? Sine over cosine, y over x. Which means that cotangent is cosine over sine. So as of right now, there's 8 identities that you guys already knew. You might not have realized that you knew them, but we've used them. We've used them in some shape or form, whether it was back in 14 when we were solving the equations, when you had to do that, or doing trig functions off the unit circle, given ordered pairs. You've done all of this. The newer ones then came into play where we had solving the equations, and I told you this. Sine squared plus cosine squared equaled what? 1. And this was called a Pythagorean identity. Because if you place theta on the unit circle, cosine was your x value, sine was your y value, which creates a right angle. 1 was always the radius of the unit circle. Pythagorean identity says cosine squared plus sine squared is 1. We did that in order for us to solve some of the equations back then, where you had a sine squared minus a cosine. You would rewrite everything in terms of cosines, or you could rewrite things in terms of sines, because you can manipulate this as what we call a literal equation. If I want to get sine squared by itself, what do I do to the cosine? Subtract it. So I can say that sine squared equals 1 minus cosine squared. Which also means I can say that cosine squared equals what?
1 minus sine squared.
Exactly. So we start to get these identities. We have all of our regulars, sine, 1 over cosecant, cosine, 1 over secant, tangent, 1 over cotangent, flip it, 1 over sine. I used to use a marker. So as of right now, we actually know 9 identities without really doing much work. There's only 2 more. There's only 2 more. There are 2 other Pythagorean identities that we haven't talked about because we didn't need to worry about them with the equations that we were setting up prior to this. I think actually one of the problems that you had for homework, I had to tell you to skip because it had secant squareds and a tangent. Well, had you known that, we could have done those problems because of identities. Remember, when I go through the trig unit with you guys, we kind of fluctuate back and forth between all the sections. We don't go in sequential order because I like to use certain parts of one section, skip ahead to when you use it, and then circle back. Or we use circle in this. Sorry, that was not a pun. But we come back to use other parts later. Okay. So you wind up with 2 other literal equations. 1 plus tangent squared is secant squared. Which means if I want to get tangent squared by itself, what do? Subtract 1. And then same deal with cotangent. Now, they use a lot of the same, tangents, secants, cotangents, cosecants. Really the only way that I was able to keep these things straight back in the day was that cotangent and cosecant both start with the letter C. And that's how I would keep them straight. Okay. Which meant that cotangent. So you get that. So we wind up then with basically 11 identities. Gentlemen, we have 11 identities. If you start piecing it together, you have 12, 13, 14, 15 by manipulating sines and cosines and tangents around by solving for each one of those independently. You already know everything up. You know that. We've been doing it for 6 weeks. I'm only asking you to know 2 more, okay? And over the course of the next 3 days or so, you're going to see how we're going to be able to use these identities to do one of 2 things. We're going to simplify statements via a whole bunch of substitutions and verify statements. Verify is basically what we call trigonometric proof. It's not like proof that you've done before in geometry where you have your 2 columns, statements, and reasons.
So you don't have to write all that?
No. It's nothing like that at all. This is a string of substitutions. What verify, and we'll get to this here in a second, what verifies, the difference between a verify and a simplify is the verify tells you what it's supposed to look like when you're done. Simplify, you're just kind of on your own, and you hope you get the right answer. And I'll show you, okay? So you can do things. Oh. You guys know me too well.
How did I know?
Oh, now I get it. That's terrible.
It is pretty bad nowadays, yes. Okay, so you guys might be becoming too young for this.
Bill Cosby there?
It's Bill Cosby.
Yes, in the jello and the pudding and the, yes. Here's why this works. Yeah, let me show you. If I want to simplify sine divided by tangent, what I want you guys to think about here is that when you're dividing things, you're multiplying by fractions, correct? Because isn't 3 over 2 the same thing as saying 3 times 1/2?
Yeah.
It means the same thing, right? So what you're able to do here is write this as sine times 1 over tangent. What is 1 over tangent? Cotangent. So that means that this is sine times cotangent. Cotangent is what in terms of sines and cosines? It's cosine over sine. Which means, what happens? The signs drop, and you're left with cosine.
Wait, so sine over tangent is cosine? Oh wait, no.
You can't, but here's the thing. If you have to verify, which this problem is what this problem is, it's telling you make it equal to it, you can't just, it's not wrong, but it doesn't, it's not the legal way of doing things. You have to, you do what's called a left to right verification, or right to left verification. There are certain rules to this, and usually speaking, we'll go left to right. There's a few problems that I have that go right left because it's a little easier. Okay, that's where this stuff is going to. All right. Cotangent times secant. What I want to do is simplify that. I want to figure out what cotangent times secant is when I simplify it. Now, there are a few tips and tricks that I'm going to show you guys throughout the day today that will help you to do the first page of a giant fun packet that I have for you. I know, it's exciting. So, what I want you to think of here, one of the first things that I can suggest is that when you see multiplication like we do here, notice how cotangent and secant are both reciprocal properties of standard trig functions. You okay with that? Which also, I could rewrite cotangent and secant in terms of sines and cosines. So whenever I see mixtures of cotangents, secants, cosecants, I generally want to rewrite them into their standard, I don't want to say standard, but the reciprocal versions of them, sines and cosines. So how can I rewrite cotangent in terms of sines and cosines? Well, can I skip that? Because what is cotangent 1 over what? Well, it's 1 over tangent, you're right,
Cosine
but
over sine.
isn't it just cosine over sine? And what's secant?
1 over cosine.
What do you get?
Cosecant.
You get 1 over sine, and what's that?
Cosecant.
Cosecant.
You have cotangent and secant. That's the only thing left.
And that's what happens. Okay. No, I'm happy that nobody said that sine was wearing a life jacket and it floated up. Nope, it's still at the bottom. Because it was still underneath the 1.
It's drowned.
It drowned. It was Jack going down the ship.
Don't start on it.
Your heart will go on.
I didn't eat skit this year. I like an
Just let go of it. Let go of it.
Hilarious. But
Let it go.
no.
Let it go. Can't hold it back anymore. Okay, let's try another one. Sine times the quantity 1 plus cotangent squared. I'm going to simplify that. Now, one of the things you can see right here is that it's telling you to distribute. Or, is there anything that you know about 1 plus cotangent squared? It's cosecant squared, isn't it?
Yes.
So you jump right to that. Would you be wrong if you distributed? No. You did. Sometimes it takes longer to get through to something, but it will still work. if you catch the quick tricks of, oh wow, that's a Pythagorean identity. So it's sine times cosecant squared. Okay. Now, yeah, there's one of two ways we can go about doing this. I can say that sine is 1 over cosecant times the cosecant squared. And what happens?
Cancels out,
Just one cosecant goes away, and you just get cosecant. Now, sometimes other people will recognize they don't like working with the reciprocal properties. Perfectly fine. There's nothing wrong with that. If you do it that way, you'd say it's sine times 1 over sine squared. And what happens there? One sine goes away, and you're left with 1 over sine, which is still equal to cosecant. You still get the same basic, yeah, you're right, you do want to put an extra step in there, but you still get the same solution as you simplify it through. There are multiple ways to go through this. There are many times that students will try and go through this whole process, especially with verify problems, and they get lost in the middle, they start making stuff up, and they kind of fall back on the right track, and they show me their work, and I said, well, why don't you just do this? And they're like, they mutter bad words and beat their breath. So a lot of times with these problems, if you get completely boondazzled and don't know what to do, just go to the next problem and then try it again later. Okay? Because you will get a mental block on these things because there's so much stuff going on. Okay? We're not doing negative angles. Verify.
Wait, so what did we just?
We simplified. The difference between simplifying and verifying is that verifying will tell you what the answer has to be when you're done. Verifying gives you a hint of what it should equal to help you work your way there. Yeah.
Do we have to write down every single step on the paper? Like, I just did one thing in my head, and like, it makes more sense that way.
What do you mean?
Like when you look at it, like secant is just like 1 over cosine, and the cancel out 1 equals 1.
Right, so all you do is this. You'd write down cosine times 1 over cosine.
But we do still have to write all the steps out.
That's all you have to do. That's really all you have to do. And you're right. Are they going to be that easy?
You
So
should,
in this class,
if
it's
you
not.
like us.
Yeah, the big word on if there.
Yeah. That's one of the 90%. Wait, was it, how much of the percentage was it that you said that you lie about?
Oh, it's like 80-20 or 15, 85-15. 85-15.
85-15.
That sounds about right.
Is that in the line?
You said yes, but I guess
Yeah, you never know.
I mean, we'll eventually get to stuff like this. This is
Can you just subtract cosines?
Yeah.
no, and this is what Nick was asking about earlier with the whole Cosby gag. You can't. What we do with a lot of this stuff is we do a left to right verification. We work from the left side to make it look like the right side. Every once in a while, it's very rare that you work right side to left. More often than not, you're going to be working left to right. So let's look at this one. We have cosine squared minus sine squared, and I want it to equal 2 cosine squareds and a minus 1. Which means, what had to be changed? What's that, Popcorn? What got changed if all of a sudden I have 2 cosine squareds? You're right. Which one changed, the cosine squared or a sine squared to make 2 cosine squareds?
Oh, yeah, you're
I changed the sign. Because sine squared is 1 minus cosine squared, isn't it? So I can rewrite this as cosine squared minus the quantity, 1 minus cosine squared. And what do you do with that negative? You distribute it. So you get cosine squared minus 1 plus a cosine squared. How many cosine squareds do you have?
Too many. I didn't even mean to make a pun.
And you're done. You're using Pythagorean identity with distributive property to get you two stuff like that.
This is all we have to do?
No.
I don't care with that.
There's a lot of that. There's a lot. Okay. So they go back to the other one. But now here's the thing, Artie. It's every problem's different. Okay. It's the idea of what are you going to look for to start it. This one I saw squares with sines and cosines, and then the answer just had 2 cosines. So in my mind, I'm thinking, all right, that means I had to use Pythagorean identity to switch one of them. Knowing that sine squared is 1 minus the cosine squared, I just use substitution to generate 2 of them. Going back to one like this then, we had one like this a second ago. We had one like this a second ago where we had it written in cotangents and cosecants or something, where I said, hey, write everything out in terms of sines and cosines. It's a great trick to remember when you are multiplying things through to rewrite each part in terms of sines and cosines. Because that's how you're going to be able to simplify fractions out. So tangents, what over what? Oh, yeah, but in terms of sines and cosines. So you have a sine over cosine. Cosecants, what over what? 1 over sine. And then we have a cosine left over 1. Hey, what happens?
They all are
No, 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 no.
That's basically all we have to do.
Not gonna help you. All right. Just watch Caddyshack like 15 or 16,000 times.
Caddyshack is an amazing movie.
Yes, it is. Go. All right, let's try another one. So here's another real tricky one that if you see the guys, thank you. A lot of times with these things, people will come up and say, I don't know where to start. Very similar to what you guys complained about with geometry proofs. I don't know where to start. And we would always say, start with your given at the beginning. So in this one here, notice in the beginning, the first one has a fraction. The second one has subtraction. They rhyme. Now, I want you to think of this. What does that equal? Why? Oh, because it has a common denominator, right? So when you have a common denominator, you're basically taking this denominator and adding the numerator together. Okay? So a lot of times, a little hint here, when you start with a singular fraction, and it ends with subtraction or it ends with addition with 2 parts, that meant the denominator got split among multiple terms. So look at the numerator. Cotangent squared. What can you rewrite cotangent squared as? 2 things.
Cosecant squared minus 1.
Right. Cotangent squared, remember 1 plus cotangent squared is cosecant squared, which means cosecant squared minus 1 over cosecant. Notice how you have 2 parts in the numerator with a common denominator, which means you can break it into 2 fractions.
And then what do you do when one of those equal 1?
Yep, that's the idea. Well, not the equal 1, I'm sorry.
No, yeah, no,
Why can't I write cosecant? What's cosecant squared over cosecant? It's just one of them. 1 over cosecant is sine. So a lot of these things, they're going to utilize the idea of taking a common denominator and re-breaking it apart. Yes, sir? No. No, because it'll be everything that if it's always a verify, that means there's going to be an answer. Because it's going to give you the answer. You just have to figure out the best way to hide the fact that you don't know how to get to the answer. For lack of better terms. Yes, ma'am.
So verify, you just want to set it up so that one side is actually the other.
Yep.
And then
You want to show how do you make this equal this.
And the other one is like getting everything. With
You try to break it down to the easiest thing it looks like. You don't know if you're done.
Is
So
this all of this?
pretty much.
Okay.
It gets
This makes sense, but I'm guessing it does here.
it gets a little bit more difficult. You know, for example,
That's not bad. What the law?
no,
Plus, cross multiply.
can't.
Oh.
You can't do that. You cannot cross multiply because if you cross multiply stuff through, excuse me, you're not verifying anything. Remember, when you're verifying stuff, you want to make the left look like the right. So now what's different between this problem and the one we just did? The one we just did, we had a singular value in the denominator. Whereas this one, we have two parts. And believe it or not, you've actually done this before. You just didn't know that this is what you were doing. How do you simplify that? Math. Very good. Yes, sir.
You multiply each side by 1 plus each side.
Yep. You multiply by the conjugate. When you multiply by conjugates, you create a difference of squares. If you FOIL this out, you get a squared minus b squared, which meant that your denominator became 1 minus 2. You did that with these. You did that with i's, with imaginary numbers. You did that with radicals, with variables. We've done this step many times. The only thing that's different now is that we're going to throw trig in it. So whenever you have a singular value up top, more often than not, and a 1 plus or a 1 minus of something in the denominator, the trick usually is to multiply the top and bottom by the conjugate. Because whenever you multiply by conjugates, you are always creating a difference of squares. You always do. Remember, this is a minus b times a plus b, a squared minus b squared. This always works. Because no matter what, what's 1 plus cosine divided by 1 plus cosine?
1.
1. The one before that, we had 1 minus root 3 divided by 1 minus root 3. 1. Conjugates are always factors of 1. They're just funky looking factors. And the reciprocals. This might be banned. The funky looking factors and the reciprocals.
I have a feeling we'll have one kid.
It's all in my head.
Just like math.
It's imaginary. I see.
Don't humor me. Don't humor me. And you get that. Are we okay with that?
Sure.
And then don't you break them into two?
I don't break them into 2. I can't because of the subtraction. But what is 1 minus cosine squared?
1 minus. That's a sense.
Sine squared.
And what drops? Yes, ma'am.
So for this, like, is the way you get points by just showing all the work? Like, where do you stop? You just stop? Like, I don't know how to word this, like,
You want to do, when you're verifying, you want to do everything you possibly can to get to here. Now,
and then
there
you
are,
just stop once you get there,
Yes.
and then you just leave it.
Yes. Yep. Because, and don't get me wrong, there are more than one way, there is more than one way to get there for a lot of these. A way that you might see it might be different than the way that I might see something. I'm just trying to start with some really basic starting points to give you.
It's like where, it was just like, how would you like your final answer?
Just like that, I would leave it. Once you get to where everything simplifies out, you know that's 1 plus cosine, and and then how about we do this thing? Tell me you're happy with it.
I'm not happy with it because we have to do so many steps. Thanks.
Okay. Now, when it comes down to the simplify, let's say you had a simplify problem, and you wound up and this was your answer at a simplify. Could you make that easier?
Yeah.
What would you write it as a cosecant? That's what I'm hoping you would do. I would stay away from fractional answers. If it's like 1 over sine or if it's 1 over cosecant, write it as cosecant, write it as sine, things like that. We had another one here.
So will you find it wrong if we leave it in a fraction?
It depends. It depends on the problem. We'll don't worry. We'll get there. We'll get there. Always worried about the points. Exactly. So this one is a simplify problem. But you have to show the steps. You're going to hate this, but you're going to have to. Secant plus 1, secant minus 1. That's showing you a what in the numerator? It's a difference of squares, right? So your numerator becomes what? Good. And secant squared minus 1 is tangent squared. And your answer is, and you're happy. Okay. What's that? Wait, you're never really happy. Well, at 246 you usually are. Sir?
Okay, so there was, okay, this might sound like a stupid question, but wasn't there one of the other problems that once you got like tan or it wasn't tan, it was tan, sine, cosine, or tan? I feel like I'm just something else. But yeah, wouldn't you put it like sine over cosine? And I sound like a complete idiot right now.
Yeah, on the other ones, because that one we started with tangent. I think it was a tangent, cosecant, secant one. Those guys were all, when you start with tangents and you have other properties with it, that's when you want to rewrite it in terms of sines and cosines to see what you can simplify out to be. In this case here, when you FOIL out the numerator, you'll see that's a difference of squares. That difference of squares generated, let me flip this on so you can see it. It generated the Pythagorean identity. The Pythagorean identity was secant squared minus 1 is tangent squared, which gives me that tangent squared over tangent, which is x squared over x, which just leaves you x. Now, are you wondering, do you have to go and do this then?
Well, I was like wondering that because I thought there was one of the other problems that we had something.
Oh, I got you. Yeah, usually, if you have a sine over a cosine, just write it as tangent. You don't need to, because that's more it's simpler to write than sine over cosine. It is. I can't remember which one it was.
Just like exponentiation.
Yeah, you guys didn't think I was. Was it this one you were talking about?
I think so.
Where we started, we wanted to make it equal 1. Well, tangent, cosecant, cosine, I know tangents as the combinations and sines over cosines. Cosecant is a 1 over a sine, and there's a cosine, and all we were doing here is just crossing stuff out. That's where we're getting at. Okay. Yeah, this stuff is kind of weird to start with, guys. Yeah, remember I was running around trying to find the worksheet? Yeah, I was writing the book before I left it. So now I have extras, so if you guys want to spare one of these. This thing's been around for 15 years. Yeah, get out of here. No problem. It's See you later. Hey, do the front page. What do you want? Yes, ma'am.
But your face, you turn around, you're like,
So, hey, look at this. We tried to make math look like it's fun. We put a puzzle in there. So, you've got 12 simplified problems. If your 12 simplified problems don't give you an answer of one of these down at the bottom, then it's wrong. Good call.
I like puzzles.
But also,
That's kind of helpful, obviously.
Okay. So, and as you peruse through, you will notice there is lots of funness within this. We're not going to go through every one of them, but it's always better to have way too many of these problems than way too few. I know. You're going to want to try and do it on a separate sheet so you have some space.